My name is Feliks. I'm a software developer at Software Mention, mostly working on the membrane framework. Today I will have a live coding session with you where I will do a demo that will allow me to have a verbal chat with ChatGPT. To do this, I will use our new tool, which is called Boombox, and a new and OpenAI Realtime API. So before my coding session, I will start with a very short presentation. So what is Boombox? Probably many of you know that we at Software Mention develop Membrane framework, which is a framework for doing multimedia solutions. But recently we released a new tool that is called Boombox, and it is a high-level tool for audio and video streaming. It's written in Elixir. It uses Membrane framework under the hood. It also uses XWebRTC, which is our implementation of WebRTC in Elixir without that doesn't use Membrane framework. This is a piece of the code how you can use Boombox. This specific example takes a video stored in a file .mp4 and streams it somewhere via WebRTC. For example, it can stream it to your personal, to the browser on your personal computer. What are the differences, main differences between Membrane and Boombox? So while Membrane is a framework, Boombox is a library. So Boombox, you don't in Membrane. When you use Membrane, you have to provide your functions, your implementations to the framework, so the framework will be able to execute them. But Boombox gives you the functions, so your code executes Boombox functions. The arrow of the dependency is pointed in the opposite direction. The second difference is that often when you use Membrane, you have some problem, you want to solve it. You can solve it with Membrane, but sometimes you have to know what specific operations has to be done in your multimedia processing pipeline. You have to know what Membrane plugins you have to use to do these operations. On the other hand, and there is some complexity that is put on the developer that he has to manage the pipeline for himself. So Boombox is designed to remove this complexity, and the API is much simpler, much more declarative than in Membrane, and it's supposed to work like you say what should be done, and then Boombox itself figures out what pipeline do you need, what Membrane pipeline do you need, and runs this pipeline. What are the currently supported formats in Boombox? First format that is currently supported as input or output is MP4. MP4 is very broadly used multimedia container that can be used, for example, to store movie in the file. We also support WebRTC, HLS, RTMP, and RTSP. All of these protocols or standards can be used for live multimedia streaming. For example, when you join a meeting, when you join a meeting from your browser with some other people, you can use WebRTC to do this. And WebRTC is implemented in all browsers. Last supported format, and all these formats, MP4 and following, are available in Elixir API and in CLI, because Boombox has CLI as well. We also support raw audio and video, but only in Elixir API. So basically you can, for example, take MP4, and Boombox allows you to inject multimedia into your Elixir code. So you can, for example, perform image recognition or AI style transfer or whatever you want on the media stream that comes out from Boombox. Yeah, you can also generate in the Elixir code. You can also generate a stream and pass it to Boombox, and for example, stream it somewhere via WebRTC. Okay, so I will also. What is the second thing that I will use in my demo is OpenAI Realtime API. It is quite a new thing. I guess it has something like more or less month, maybe month and a half. It is new API that allows you exchange raw audio with ChatGPT. So you don't. So you pass raw audio to OpenAI server. You also receive raw audio from the OpenAI server, and it does basically two things. Maybe not basically two things, but it gives two advantages. First one is because you don't have to perform speech to text and text to speech on your own. It really simplifies the code. For example, in my demo would be much more complicated without this API. And second, I think even more important thing is that it reduces latency. Because when you have a verbal chat, the latency is very important thing. And when you do, for example, speech to text, you have to choose between good quality and latency. Because this API passes raw audio to the model and model generates audio, the latency is really, really slow. Okay, so let's code something. In my demo, I will set up an Elixir server that will do basically two things. It will connect the browser via WebRTC and will exchange the audio with browser via WebRTC, and will connect to the OpenAI server via WebSocket and exchange audio with the OpenAI server using Realtime API. Okay, so I have created already a small project. I will show you the dependencies that I have.
Larger, sorry.
Okay. Is it big enough? Nice. Okay, I have only two depths in my project. First one is Boombox. Second one is WebSockets. It is Elixir library that will allow me to work with WebSockets. So I will go now to my demo, and I will start with implementing WebSocket adapter. I will do this in this module. First function is start link. It basically it connects to the OpenAI server, passes OpenAI token to the WebSocket, because to use Realtime API you have to have a special token. It also initiates the state of the process that will handle WebSocket. Yeah. The next function is send audio. That will be used. This function will be used to send audio to the OpenAI server. So, to be able, OpenAI ChatGPT expects raw audio. I mean, the audio that is not encoded with any kind of codec like Opus or AAC. But to be able to serialize the audio into the JSON, I need to encode it with the base 64. This is just the format that is expected by OpenAI. Okay, so this JSON will be converted to the encoded as a string and then sent via WebSocket. In my implementation, I decided that the audio that comes from the ChatGPT will be accumulated in the process of the WebSocket, and then Boombox will get chunk by chunk this audio from this accumulator. As you can see in the start link, I have created initial state of this WebSocket process. That has one field. It is response accumulator. On the beginning, it is just empty binary. Now I will implement a function that will get the chunks of the responses from the ChatGPT. So since there is no handle call in WebSockets, I have to do something like this. But it works just like as a Gen server call. I have a related handle info to this get response chunk function. So the API is, I call the get response chunk function, and I specify how many bytes of response I want to get, how many audio of response I want to get. So I have my accumulator, state.response accumulator, and I have to handle two cases. First case is that I have enough data in my accumulator to satisfy the whole demand. In this case, I will take the appropriate data from my accumulator. I do this with this pattern match. I will send it to the guy that asks me about the chunk, and I will save the rest of the accumulator as a current accumulator, so I won't send the same piece of audio 2 times. The second case is when I don't have enough audio. For example, 30 seconds ago, ChatGPT generated 30-second long response, send it to me, and now it's over. Like I don't have any more bytes in my accumulator, but WebRTC still expects some data to be sent to it. So to don't have any problems with that, I will send what's left in my accumulator. Maybe it is nothing, maybe it's something, but not enough to satisfy the whole demand. And I will fill what's the missing bytes with silence. And I do it here. And of course, I set my accumulator to the empty binary because there's nothing more to store. And I have to also implement handle frame callback in this WebSockets adapter to be able to handle frames that arrive from OpenAI server. Okay, so first type of message that I have to handle is response audio delta. So when ChatGPT generates the response, for example, it might have 30 seconds. It's not sent in one big message, but it's chopped in the smaller chunks, and each chunk is sent in the message that has this one type. So what I will do here is I will save the audio the chunk of the audio in my accumulator. And because the audio that comes to us is encoded with base 64, I have to decode it. Okay. So another thing is in the Realtime API, when new response is generated, before first chunk on the beginning of the response, I also will receive a message that has type speech started. So let's imagine the case where ChatGPT generates a response that has 30 seconds, but after 10 seconds of hearing this response, I want to interrupt the ChatGPT. For example, I want to ask different question or whatever. And after receiving my words, ChatGPT, after, for example, 20 seconds from the beginning, generates another response. So in this case, I don't want to wait till the 10 missing seconds because the initial response was 30 seconds. I don't want to wait on the end of the first response. I want to cut it and just play the new one. So in this case, I will set my accumulator to empty binary. So in case of new response, I will drop the old one, basically. This API beyond sending raw audio, it also sends transcription of the generated responses. So when it will arrive, I will log it on the standard output to be able to see what AI has said, to be able to debug it. If, for example, if I will meet any problems with the sound, so because I have already implemented my WebSocket adapter, I will spawn one. I will feed it with the token that I have fetched from the env. And now we have already implemented we have our Elixir server, and we want to connect to the OpenAI server. We want to connect to the browser, but and we have already implemented the connection between my Elixir server and OpenAI. So now we have to take care of the connection between Elixir server and browser. To exchange multimedia between a browser and my server, I will use WebRTC, and I will spawn two Boombox instances. One instance will be responsible for getting media from the browser and passing it to the OpenAI. Second one will take the OpenAI responses and will pass it to the browser. So this is the Boombox that you can see on the screen. Is responsible for getting media from the browser via WebRTC. This is the address of WebSocket that will be used to exchange signaling messages. There will be no media going through this socket, but in WebRTC you just have to, before establishing multimedia connection, you have to have some kind of signaling channel, for example, to tell the other side of the connection that this is my UDP port that I will listen on, for example. And this is input of our Boombox instance. The output is stream, is Elixir stream. I also will specify that there will be no video files, there will be no video here, and I expect audio with this format. This is basically the format that is expected by OpenAI, so I have to adjust to it. And this Boombox will return Elixir stream that will have, and each element of this Elixir stream will be packet having payload being audio from the WebRTC, from the browser. So I will handle this stream with enum each. Each element of the stream will be Boombox packet struct and with the field payload, and this is the only field that is important to me right now. And for each payload, so for the audio that comes from the WebRTC, I want to send it via WebSocket to the OpenAI server. So I have to just call the function that I have already defined, send audio, and put the audio here. Okay, so now I will go to the second Boombox that gets ChatGPT responses and send it to the browser via WebRTC. I decided that every 20 milliseconds, okay?
Payload, name of the variable.
Ah, thank you. One bug less to debug when I will try to run it. I decided that because WebRTC in the specification WebRTC WebRTC expects to, like, I cannot just stop sending audio to WebRTC because there should be a flow of the media all the time. I decided that every 20 milliseconds I will send a 20 milliseconds long audio chunk to the browser. So I have defined this variable says this is number of the milliseconds. This is the byte size of the raw audio that has 20 milliseconds. It is calculated using this equation, and now I will pass this chunk duration millisecond to stream interval. It will produce a stream that will contain following natural numbers, I mean 0, 1, 2, 3, etc. And each number will arrive after 20 milliseconds, because I have passed here 20. And I have the stream, so I want to map every number to a Boombox packet. So every 20 milliseconds, this stream will generate Boombox packet having ChatGPT answer, or at least chunk of the answer. To generate this packet, I have to fill the missing fields. The first one is payload. Payload should be the ChatGPT answer. So I will get the answer from the from the WebSocket process, because the answers from the ChatGPT are stored in the WebSocket process. Get response chunk, WebSocket, and I want my chunk byte size number of bytes. Okay, I have to set kind to audio, and I have to set also PTS field. PTS stands for presentation timestamp. So let's calculate presentation timestamp. I have to calculate presentation timestamp of the packet. I have to just multiply index of the packet, number of the packet, by chunk duration. But Boombox expects PTS to be expressed in the membrane time unit. So all I have to do now is call the function which is called membrane time milliseconds, and pass the number of milliseconds. Okay, so now I have created my Elixir stream that is passed directly to the Boombox. And this Boombox expects, since input is set to stream, it expects Elixir stream on the input, and output is set to WebRTC. So the stream that I have just generated in the Elixir code will be sent via WebRTC to my browser. Okay, I have already implemented both Boomboxes, that each one responsible for one direction of the data flow. One thing that I also have to do is to run this Boombox in the separate Erlang process. Because normally the code would stop at the line 105, and it would wait till this Boombox run ends. So all I will do is I will wrap it into task start. So the both boxes will run in the separate processes, will run parallelly. Okay, so let's try to run my demo. Okay, it compiled. Now I will go to the browser and try to have a conversation with ChatGPT. Hi.
Hey there. How's it going?
Quite nice. I'm just having a presentation on the meetup at Erlang Solutions.
That sounds exciting. Presenting at a meetup can be a great opportunity. What's your presentation about?
About having a demo that allows me to have just this conversation with you right now.
That's fantastic. Giving a live demo of a conversation during your presentation is a bold move. How can I help make this demo even smoother for you?
Do you want to say something to the audience?
Do you want me to? Hello, everyone at the Erlang Solutions meetup. I'm excited to be part of.
Okay, sometimes no. Sometimes it doesn't work 100%.
This demo.
Okay.
Feel free to ask.
Sometimes it doesn't work 100%. Okay, maybe like some scratches were recorded by the microphone, and I don't know, some and the accumulator was dropped or something. I have no idea, but yeah, this was my presentation. Do you have some questions? I don't know if we have time for questions, but let's ask your one. Nobody interrupted me yet.
Do you have any estimate what was the cost of running this short conversation?
This one,
Rough estimate, $1 fraction of dollar.
I think that you know, like up to I probably this one was up to $1, maybe $1. It's a good idea to okay, it's crashed down after closing the browser. Yeah, so I wanted to ensure that I don't have like a chat.
It's just $1.
Yeah, you know, like I think that this was just $1 when I was developing the demo. One day of like the cost was not very high beyond 1 day, when it was like quite higher than I expected. But yeah, when you look at the estimations at the OpenAI website, it doesn't look bad. Maybe like there was. I'm not sure if maybe there was 1 day of development this demo when it charged me more than I expected, but maybe it was because I was doing something wrong with Mida and I was sending too much data to the server or something like this. Yeah, but.
Could you ask it how much it costs?
It can get into a loop, you know, updating the number every time it sends you a data.
Hi, what's the cost of 1 minute of the generated audio by you?
I'm sorry, but I don't have information on the cost of audio generation. Pricing for services like that can vary depending on the provider and their specific pricing models.
Okay, so what I have saw on the what I have saw on the their website, the price is not like there is one price, yeah. But I guess that it is more expensive than having speech to text and then send it to the ChatGPT and vice versa.
And what about the transcription? So
Transcription, okay, we can take a look at them. Sorry, but funny thing is that before sometimes when you run this Realtime API, as you can see here, yeah, it's very often if you don't say anything at the beginning, it often starts with Spanish "Hola, ¿cómo estás?"
it feels uncomfortable in silence here.
But it
does it send you the transcription of your speech?
No, because it also only it doesn't do any as far as I know, there is no speech to text on the AI model, but the ChatGPT works like a little bit like this, that it takes a text and it tokenizes it, and then it does some operations on these tokens, and then generates tokens that are then, as far as I know, converted into a response text. And now it happens the same, but with the audio. So the audio is tokenized. The raw audio is tokenized. There's like you take the audio and you tokenize it, and there is no text in between these two. So there is a big chance that nobody, like when I'm having a conversation with this using this API, there is no transcription of my words at all anywhere. And this is the thing that that allows the chat to reduce latency. Because normally when you write a chat that does speech to text and then passes it to ChatGPT and takes the response, does text to speech, I think that it's very hard to go below 1 second of latency. And it gives you, like, when you have a conversation with the verbal assistant, it gives you very weird feeling if the latency is too big. So the experience is not okay, and this model sometimes maybe it generates weird sounds, but the latency is like, I have no assaults to it.
So if we go down the route speech to text and then text to speech, I guess membrane Boombox would be useful as well in converting your voice through WebRTC and then passing the voice to appropriate model, right?
Yeah, you could use the same, I guess, exactly the same two boomboxes to get audio from the WebRTC. Then you would have to do speech to text. You would have to pass the text to the GPT, and then vice versa.